Hello friends, this is David Cuartiez, co-founder of Arduino, and I'm here today in the second episode of the second season of the Arduino LiveCast series. As you see, it's getting a bit colder here in Sweden. It's only October, but it feels pretty cold. I have to wear my hat indoors. I'm here at my shed and the temperature is not really optimal, so you're gonna be seeing me sipping a bit of tea every now and then. So as you know, we're troubleshooting the livecast, so feel free to comment on the Discord channel that you see the link below in the settings for this video, whether things are working or not for you. Thanks for the comments we got last week about sound. I think we worked these things out pretty well to normalize the audio volumes a bit better. And let's see what this week is bringing us. As you know, the idea of the livecast series is that we're gonna get people sending us challenges, and we will combine those challenges with some learning goals that we have to fulfill our pedagogical mission here in Arduino Education. Well, this week we're still getting some comments from Josephine and Carl, the laboratory assistants for Malmo University's IOIO lab that are helping out setting up this livecast series. And you see here Josephine and Carl that are on top of my shoulders, acting like the evil and the angel that let me know what I have to do. And anyway, they're gonna be with us for a while, recommending which kind of projects we can make. And this week we're gonna make a small project where we're gonna learn about photodiodes and RGB LEDs. As you know, this livecast series intention is just opening up the possibilities for you and giving you ideas on what you can do. There is always more documentation you can find. It's not the goal to go very much in depth in some of the concepts. For that, we will make some other videos later on. Okay, so let's see what we have for this week. So first of all, just remind you that this video series is sponsored by the eCraft to Learn European Research Project that Arduino is part of, together with some other people. And the idea here is to help out teachers across Europe and obviously across the whole world to get access to basic technologies to include in their projects, but also to learn some basic things that might get handy when they're discussing about which kind of projects to build together with the students. In this project this week, we're going to be working with the Arduino Uno, as you know, the star of the Arduino portfolio. And as you know, this board is an 8-bit microcontroller board that has 20 inputs and outputs. 6 of those pins can be used as analog inputs, and that's what we're going to be working with today, because we're going to be using one of those inputs as a way to detect that there is a signal coming in the microcontroller, and on the other hand we're using 3 digital pins that have the ability to write PWM, which is pulse width modulation, to control the intensity of light in 3 pins that are controlling an RGB LED. So we will be using the Arduino Uno. We're using an RGB LED like this one, as you see. This is an RGB LED where has a common pin that will connect to ground, and 3 pins that are for the different types of light. In case you have never really discussed about this or read about this, let me remind you that the light is composed by the intensity of, or the mix of the intensity of 3 lights of different intensities, which is red, green, and blue. Which means that if we basically have 3 lights, 1 red, 1 green, and 1 blue, we can compose any kind of light in the light spectrum by changing the intensity of each one of those lights. In this case, it's possible to integrate those 3 LEDs in a single housing, and what we see here is a very simple RGB LED that can be controlled with 3 pins independently. There's other technologies that make this easier in a way that it allows you to add a lot of more LEDs by daisy chaining them, but this is a very easy way to have a starting point to work with LEDs, where you control directly the intensity of light by changing the input to each one of these values. We'll also be using a photodiode, and a photodiode is a device that reacts to the amount of light going onto it. And in this case, the this is going to add some sort of a light switch. It's gonna detect intensity of light, and depending on the amount of light that goes onto it, we will be changing the kind of light we're gonna be representing with the RGB light. So we have the Arduino Uno, we have a breadboard, we have the RGB LED that I so much spoke about. Here are the pins that we will be using. The minus pin has to be connected to ground, and the RGB pins are connected to outputs on the Arduino board. This small module is pretty convenient because, as you can see, it already has, and let me see if I can see my mouse on top of the screen, it already has the 3 resistors that are needed in order to control the LED itself. And then we have the photodiode, and the photodiode has that tiny capsule up there. It looks like a tiny LED, but it's not. And that tiny capsule up there is the one that contains the light detection system, and it has to be controlled with or polarized by using a resistor. And in this case, we're using a 220 ohms resistor, if I'm not mistaken. It's red, brown. And this resistor will be connected in series to the photodiode, and from the union of the photodiode and the resistor, we'll have an input to an analog pin on the Arduino board. We need some jumper wires, some more jumper wires. The first ones were female male that we will use to connect the RGB LED straight into the Arduino board, and some male I will use to connect things onto the breadboard. This is the circuit view of what we're going to be doing. As you see, we're using a breadboard to connect the photodiode. For real, the RGB LED is not going to be connected like that, because if you remember, the module looks like this, as I was showing to you. So we don't need to plug it on the breadboard, even though we could. We're going to instead use some wires straight into the RGB LED so we can move it around freely. You will see very soon how it's connected to the Arduino board. So before jumping into projects that are using this, let's take a quick look at what we have here. So here we have already the circuit pre-mounted, so I don't have to use time on this. We have an RGB LED, so we can take a look at it, and we have a photodiode with some extra resistors. This is in case I go wild and I break something, but nothing's gonna get broken today, don't worry. No electronic components will suffer during the making of this video. So here we have the Arduino Uno board that I have to program, the breadboard with the photodiode that is connected in series with the resistor. As you see, the white cable is the one that's carrying the signal back to the Arduino board, and on the other hand, there is 5 volts that are connected to one of the pins of the diode, and the ground that is connected to the other pin of the resistor. So basically, this is the same kind of circuit you will make with an LED, where you can put a resistor to polarize the LED. In this case, we have a diode that's going to be stimulated. And if you want to read more about the different kinds of sensors, because this is a photodiode we're going to use, the advantage of the photodiode is that it's not so sensitive and hard to configure as an LDR, because many of you will be familiar with LDRs. I'm going to just show you, let me see, this is my desktop, it's a bit messy today, and let me see my browser. Oh yeah, I have my browser on a different window, but I'm going to be bringing this up, and if I'm not mistaken, now you can see on the browser, you can see this website that is called www.lprocus.com/phototransistor-basic-and-advantages. And this is a very interesting article that is looking at different things that can be used to detect variations of light. And it starts with LDRs, and it continues with phototransistors, and goes on to talk about photodiodes, and there is even photo Darlington pair. So there is different types of ways of detecting intensity of light. We're gonna use the photodiode today, and the advantages of it is that it is, sorry for that, it is low cost, is temperature sensitive, which is not an advantage, but it's very convenient because it is very simple to use. There is other components that can be used to detect, for example, infrared light, which is a phototransistor, or intensity of light, as it is the LDR. So advantages of each one of those components is something you can check only empirically, and I will recommend that you try out different things whenever you have the time to make sure that you have things that adjust to your needs when you are working on a project. It is very different to use different things, and it's good to adjust the components you have to the situation. For example, an LDR it behaves pretty well on your desktop, but the moment you move it to a different environment where the light conditions change a lot, then your whole program tends to fail. Okay, so we have the circuit there. Let's take another quick look at it. And here it is. And what we're gonna do now is take a look at the software to see how it behaves. And let's open the Arduino software. We have it here, and I have a program that has already been made so that we can use it quickly. And as you see here, it's having a pin for the photodiode, which is going to be A0, a variable that's called photo value that's going to be used to store the reading, and there is 3 different pins for the red, green, and blue lights, and they are chosen on pins 5, 6, and 9, and those pins have been taken intentionally because they're pins that can issue PWM signals, which means a train of pulses, will allow you to control the intensity of light. Those pins on Arduino boards are the ones marked with a tilde sign. In the setup, we configure the serial port to monitor the readings from the sensor, and we configure the 3 pins for the LEDs as outputs. And later on in the loop, we read the value as an analog signal. We print out this value to see how it looks like. And then here there are some thresholds that have been adjusted by Carl and Josephine for us to check how to turn on the lights depending on how the values are in different thresholds. As you can see here, what this program is doing is to write analog signals on different pins, and is writing different sets of values so that the lights change in color. So it's a mixed color. It says here strange color for when we cover in the photoresistor. If the hand is really close, it goes blue. If the hand is halfway, it goes green. If there is nothing on top, it goes red. And if we use intense light on top of the diode, it will turn purple. And there is a final delay here not to saturate the serial port. And I always say this in all of my videos, and I will remind you again, if you make a program that is using the serial port and you don't use a small delay as a way to finalize your sending data back to the computer thing, you will saturate the serial port on the computer side. And when you try to send a new program, before the computer can send a new program, it needs to flash out the data that arrives to the serial port, and that will take some time, and it might time out sending the new program to the board, and might give you some trouble. So it's always good to have some sort of delay, even though it's small, like 50 milliseconds, 100 milliseconds, so that the computer has enough time to flash out things, because there is not too much information that arrived on the serial port. Okay, anyway, let's try out this program and let's see if it works. And it might work right away, or it might give us some trouble, especially on the area where we're working with different thresholds. We will just first check that it compiles. Let's see if it compiles properly, and it seems to compile no problem. Just wait for a second. It seems to compile. So the next question is, whether it is working as expected. And you see the instructions are written in the program. So I will just plug the serial port to my Arduino board, and this one. There it is. Here, I remind you, here's the sensor. So the idea is that now we'll be activating the sensor that I will be changing. Right now, I still don't have the right program on the board. So if you see the light flashing, it's because the board might have whatever old program it had from before. I will make sure that on Arduino I have the right serial port and just send stuff up to the board. Okay, so I'm sending the program now. Alright, the program seems to be running on the board, and now it's time to check that everything works as expected and that I don't need to troubleshoot things in a weird way. So I try to cover, I don't see a change on my sensor when I cover it with my hand. I try to cover it better. I don't see a real change on my sensor. I take off my hand. I don't see a change on the sensor. Could be that the light is very intense, but at this point I think the clever thing to do is to open the serial port monitor and check that things are working as expected. And in order to make this work properly, I will just move my Arduino IDE to the other window so that I can work simultaneously with everything. I will just move this out like this, maximize this window so you can get full view, and I can open the serial port monitor, and now you can see a serial port monitor and you see the signals that it's reading. When there is nothing on top of the sensor, I'm reading a value between 1 and 4. If I cover it, it goes down to 0, and you see. So probably what happens is that the light conditions are a lot better in my lab than they are at the place where Josephine and Carl were trying their program. So this is an issue, as I told you. It's very typical when you work with light sensing that the light conditions are very different in the different setups where you try things out. And what can you do to fix this? Well, the only thing you can do is to try to fix the programs. The problem right now is that the range of signals I'm getting is pretty bad. As you see right now, it is probably too dark for my sensor in general. Like, it's pretty dark so that there is no big difference between covering up the sensor completely with my hand and releasing it completely and let it out in the wild. So one thing I can try to do is to bring in some lights. I will use the flashlight from my phone as a way to ensure some extra light on top of the sensor. So there it goes, flashlight. And when I illuminate the sensor with my flashlight, you see how now the light conditions change and it goes over a certain value. And if I cover it with my hand now, you can see how the light conditions totally change. See? So the one thing that happens is that it's really hard to see the light changes on the sensor because it's really intense for the camera. So it's pointing directly to the camera, so you don't see the color changes. So one trick, if you want to show this on camera, is to cover up the light with, for example, a piece of paper. I'm going to take just a tiny piece of paper and cover the sensor. So now we might be able to see how the light quality changes. Okay, so the last thing that happens is that the code is not written properly. And it's a classic thing, because the way this code is written, as you see, is not okay. It should be just giving me two parameters for the function analog write. So if I want to write a certain color, I just need to write one single value for each one of these. So as you see, Carl and Josephine keep on putting traps on my code. So small things matter. And this is something I face on a day-to-day basis when working with code, because I'm teaching a lot of students, and they build their programs how they have understood things work, and it doesn't mean it's necessarily the right way. And even though the program compiles, it still is not probably the way it should be working. So when you as a teacher are checking programs, don't think that the fact that the code is compiling properly is a guarantee for it to work. So to be completely honest, I knew this program was not going to work. I saw that I made it compile just to show you that you have to check things out. Finally, once we have this thing working, since the threshold we're getting now for our project is very tiny, we have to adjust the threshold to work with the lights we're having. Okay, but first let's fix this. So now the code is properly written. Now we'll just check. Next we will just check with the lights that that the readings are okay. You see the readings, and you see now clear changes in the light intensity. You see, well, you don't see it, but I can tell you the light goes from blue to to red. Let's see if I can move the camera, or even better, I can use I've made my own sandpaper filter for lights here, and I didn't think I'm gonna need it today, but this is basically a piece of transparent plexiglass that I sandpapered on both ends, so it's translucent but not transparent anymore. And you see now how it's diffusing the light, and now you can clearly see how the light changes much better. Okay, so it's another trick. You can do this with paper as well, by keeping the paper at a longer distance, but it's not as good reception. Just for the sake of clarity in the video, I'm going to use this one. So you see, as I change the intensity of light with my flashlight, the light also changes on the sensor. So let me just turn off the light. So we learned something today, and we've seen a couple of interesting things that you can apply when you're working with in class. First of all, we saw how to use the analog write function that is sending a PWM signal. We will go more in depth into what PWM is in a different session, but you see it can be used to change the intensity of light. By changing the amount of light in each one of the pins of the LED, we are changing also the light value, and we're mixing different lights. We saw how to use a photodiode to measure the light coming on top of the sensor. We saw that the light conditions in my shed, even though they are actually pretty good for even video, are not so great for detecting this sensor. So if we want the sensor to work, we have to have a clear light pointing on it. So it could be great, for example, for an installation where you have different light sources and different sensors, and where you just pass your hand on top or things like this. And we also see how to have a trick on how to show LEDs on video, a piece of translucent material. Paper is translucent, it can work, but it's not as good as sandpaper plexiglass. So it's a pretty good trick. Just for the fun of it, and because it is Halloween, I made my own Halloween filter. So here you can see, very nice for future Halloweens. Okay, so after recapping, as you know, in our LiveCasts, we always have some extra things to say. We always like to refer to other people's projects, so let me just go back to the presentation. And one very nice project is this one that you can check on Arduino's Project Hub, which is, as you know, Arduino's project repository for projects made by users. And this is a dog color that changes color, and you can, right now I'm trying to have an LED LEDs on your dog, so when you walk your dog at nights, it's easier to see it. And well, this one is pretty cool because it's controlling the kind of light on top of the LEDs. And if you want to see another example using photodiodes and phototransistors, there's also this other project on Arduino Project Hub, which is the obstacle sensor. And the interesting thing on this one is that it's making its own obstacle sensor at a very low level using an infrared LED and a photodiode, or actually phototransistor in this case. So the idea is that you can have a sensor that is detecting not just normal daylight, but it's detecting infrared light. And this is very convenient when you want to make a sensor that is typically used in a robot to measure distances or to detect line painted on the floor. And you can make your own with discrete components, so you can one that is already made. This particular project on Project Hub, it's very handy for you to learn how to make it from scratch. So if you need to explain your students how it works from zero, this could be a really good way to do it. There is some other projects in Project Hub that I recommend you check, like there is, for example, examples on how to use photodiodes or phototransistors to read the human pulse, where instead of sending infrared light, you use a normal red light, and you listen to the echo of what is responding by the finger, because the blood flowing through our finger reflects red light. So you can use that trick as a way to measure the blood pressure, or the heartbeat to be precise. Okay, with this, friends, I want to let you for this week. Thank you very much. Remember to subscribe to the Arduino LiveCast series, and we'll see you next week with some more exciting projects and hopefully a better working heating. Thank you very much, and see you soon on the internet.